Okay, so let's continue on. The last lecture we left off here, constructing a probability histogram. We're going to do example 6, but before we do, let's just talk briefly about a probability histogram. So we've made histograms before, right, in chapter 2, and it looks like a bar graph, but the bars touch. We're going to make a very similar histogram, but now for a discrete probability distribution. And the values of the discrete random variable are going to go along the horizontal axis, while the corresponding probability values are going to go along the vertical axis. So if we look at example 6, it says, according to the highway department in Prairie City, Idaho, the number of passengers per car, including the driver, commuting on Highway 57 per evening is defined by the following probability distribution. So my random variable X represents the number of passengers, per car, meant to highlight that. So the number of passengers per car, that's what X represents. And X is discrete, right? It can either be 1, 2, 3, 4, or 5 people per car. And then listed right next to it in the other column is the probability of X. So the probability that there's going to be X amount of passengers per car. And this is a valid probability distribution because each one of these probabilities is between 0 and 1. And if we were to sum up all the probabilities, they add up to 1. So we do, in fact, have a discrete probability distribution here. Now, before we answer the questions, I just want to point out why this might be important. So think about how this could relate to us here on Long Island. I know it's hard to relate to in Prairie City, Idaho, on Highway 57, but imagine we have cars commuting in the evening, right? Evening typically is rush hour, right? People are going home from school, from work, and on the highways, there tends to be a lot of traffic. So if we relate that to here, for us on Long Island, let's imagine the Long Island Expressway, right? In the evening, gets very busy, a lot of traffic. So why might we want to create a probability distribution? Well, maybe the Department of Transportation here in New York is interested in freeing up traffic in the evening commute. So if they realize, you know what, most of the people are driving either alone or with one other passenger, right? Because both those probabilities are 0.35. If we add those together, that's like 70% of the distribution right there. So it's not very likely that there's going to be more people per car, like 3 or 4 or 5. So you'll notice the probability actually gets smaller as the number of passengers per car increases. So you could think that's why the HOV lane was created on the Long Island Expressway, right? Because there's a requirement. You're not allowed during rush hour in the morning and the evening to drive alone on the HOV lane. You have to have at least another passenger with you. And the point of that is to get cars off the road, right? Because if you carpool with your friend goes in the car with you, and now your friend's car is not on the road. So if everybody paired up or had 3 people in their car when they were commuting, there'd be that many less cars on the road, and it would have, it'll make for less traffic. So a study might be done for that reason, right? Something like this might be helpful when constructing a highway or maybe adding lanes in order to alleviate traffic. So I just wanted to point that out, just something to think about, because I like to point out realistic, interpretations of a lot of the things that we do and how it could apply to real life. So let's answer some questions. So it says, for this probability distribution A, identify the values of the random variable. So in other words, what are the possible values of X? So the possible values of the random variable are 1, 2, 3, 4, or 5. There's no other possibilities, right, for this particular study. So now let's introduce this histogram concept. So let's construct a probability histogram and we'll determine the shape of this distribution. So remember, a graph is nice because it lets us see the shape of a distribution. So we said we always have to have a vertical and a horizontal axis. And this is going to be a probability histogram for the number of passengers per car. Now, like I stated above, the horizontal axis is going to represent the values of the random variable. And we said the values of x are 1, 2, 3, 4, and 5. And now on the vertical axis, we're going to list the probability. So we're going to list P of x. And I would just take a quick peek, right? Our probabilities range anywhere from 0.05 all the way up to 0.35. So let's just make sure we include those values in our scale. So I'm just going to start at 0.05. And let's count in 0.05. So if I add 0.05 to that, I'm going to get 0.10, add another 0.05, 0.15. We just want to get up to 0.35. So then we're going to have 0.20, 0.25, 0.30, and then 0.35. So now we're going to construct, and let me move this over just so I have some space. So now we're going to construct the bars or the rectangles. So the first one is going to go over 1, and 1 has a probability of 0.35. So the height of the first bar is going to correspond to the probability of that random variable. So the height's going to be 0.35. Next, we have 2. X equals 2 with a probability of 0.35. So it's going to be the same height, this next bar. Now the bar over 3 is going to have a height of 0.15 because that's the probability that x is equal to 3. The probability that x equals 4 is 0.10, so the height of that bar is going to be 0.10. And then the probability that x equals 5 is 0.05, and that height is going to be 0.05. So this is what this table would look like in the form of a probability histogram. And again, it's nice to take tables or data and put them into a nice picture or a graph because it lets us see the shape, right? So if I take my pen and gently trace the outline of this histogram, it's pretty clear, right? What shape is this? This is skewed, and it's skewed in the direction of the tail, which is to the right, right? So the shape is skewed right. So it's more likely, there's higher probabilities that there's going to be 1 to 2 passengers per car. As the number of passengers increases, the probability decreases. Therefore, we have a distribution that's skewed to the right. So let's look at part C. Find the probability that a car will contain exactly 2 passengers. So let's practice putting that sentence into probability notation. So remember, we say the probability that, right? We use P and then open a set of parentheses, and we want that a car will contain exactly 2 passengers. And remember, we're using X to represent the number of passengers. So what I'm really saying is, what is the probability that the number of passengers, which is X, is equal to 2, right? Is exactly 2. So this is what we're looking for. So let's go to the table. The probability that x is equal to 2, if we look to the right, is 0.35. So there's a 35% chance that if you were standing on the side of the highway and you took a car at random, it's going to have 2 passengers inside. So let's look at the next part. So D says, what's the probability that a car will contain at least 3 passengers? So we want at least 3 passengers. Before we answer this question, I just want to hop over to the whiteboard for a minute and just go over the difference between at least and at most, because you are going to see that a lot throughout the rest of the semester, and I want to make sure you're using the appropriate inequality. So let's just go over real quick the difference. Okay, so at least. So if I said I have at least $5, let's say, that means I have $5 or more. So at least means greater than or equal to. So whenever we have that little line underneath the inequality, that means included or equal to. And sometimes we're going to see the words at most. So if I said I have at most $10 in my pocket, that means the most I could have is 10, but I could have anything less. So I could have less than or equal to 10. So anytime we see the words at most, that implies less than or equal to. So this is greater than or equal to for at least, and at most is less than or equal to. Okay, so just make sure you know the difference between the two. So let's go back and let's answer now the question. Find the probability that there's going to be at least 3 passengers. So what's that means is, what is the probability that the number of passengers, which is X, is at least 3. Now, remember, at least, that's greater than or equal to. So what is the probability that X is at least or greater than or equal to 3? So if we look at the table, greater than or equal to 3, that includes 3, right? And anything more. So on the table, that's the X values 3, 4, and 5. Those are all the values that are greater than or equal to 3. So what we have to do is we have to sum up their respective probabilities. So we're going to add up the probability that X equals 3 plus the probability that X equals 4 plus the probability that X equals 5. So we're going to have 0.15 plus 0.10 and then plus 0.05. And that's going to equal 0.30. So there's a 30% chance that a car is going to contain at least 3 passengers. So just more practice reading a probability distribution table and answering some probability questions, just like we did in the previous lecture. So in addition to calculating probabilities or answering questions regarding the shape of a probability distribution, we can also calculate the mean and the standard deviation of these discrete random variables. So just a quick reminder, the mean, so we talked about the mean and the standard deviation in chapter 3. The mean measures the center, right, or the typical value of a data set. So in this case, the mean of a discrete probability distribution is going to describe the center or a typical value of our probability distribution. And another word for mean is expected value. So we could also say, well, what do we expect? So whenever we say expected value, we mean the typical value of a probability distribution or the mean. And we can also calculate the standard deviation. And standard deviation, remember from chapter 3, measures the spread or the variability of a data set. We could calculate the standard deviation of a probability distribution, and it's going to measure the variability of the distribution. So in the next lesson, we're going to continue this example, the one with the number of passengers per car. And I'll show you how to calculate the mean or the expected number of passengers per car in the evening, and then the standard deviation.